the maximum value of a trigonometric expression. And this part gets left out quite a bit, but I'm going to just go ahead and put it in the universal quantifier for all, theta. Theta is typically measured in radians. Now, notice this trigonometric expression is in quadratic form, so it's a little easier to look at this perhaps just is a squared minus 30a minus 9. Now, there's a vertex formula that actually is derived just from completing the square. So we'll just go ahead and complete the square here. Notice that this is equal to the binomial a minus 15 quantity squared. Now, I'm going to stop right here and just, the reason why we do this is because when you expand this, you certainly get a squared, then you get 2 times a times negative 15, which is the minus 30. But you also get an unwanted number, namely 15 squared. So I'll put plus 15 squared here. And actually we need to put, we need to make that, let me erase that. We should make that minus, I suppose. I mean, that's necessary. Minus 15 squared. See, we don't want the 15 squared because there's not a 225 anywhere inside, right? So we're subtracting our mistake in a manner of speaking. And then minus 9 is still there. It hasn't committed any infractions. Okay? So it's crucial to understand that this piece right here is exactly equal to this. And this is the pith of completing the square. And this is the reason why you take half of the linear coefficients, because when you expand it out 2 times, that number happens, which will bring you back to the number you're interested in. But also you generate this passenger 15 squared. You would have a plus 15 squared here, which isn't present here, so you subtract it off. Okay. Now the very same kind of reasoning is used here. Now, by the way, if we were trying to find the maximum value of this, let's see, what would that be? I don't know if you really, you can find the minimum value of this, right? I'm not sure about the maximum value. I don't know if you can really. No, yeah, this is just something that grows and grows and grows, right? So the minimum value of this would happen at 15. However, we're dealing with a trig function, so things get a little different. So what we have is this expression, and the big observation here is to note that from trigonometry and the unit circle definitions, cosine theta is bounded, as is sine theta. Okay, so there's no real difference in working sine or cosine theta other than the location of the numbers, the important numbers. So again, the lower bound for cosine theta, based on the unit circle definitions, is -1, and it can't get any bigger than 1. And you know it does equal to 1 when theta is equal to 0, and it's equal to -1 when theta is equal to -1. That's not really germane right here. What is important is that -1 will make this expression as big as it can be. If you put a -1 right here, you get a -16 quantity squared. And that's when this part is going to be as big as it can be, which in turn will make the whole thing as big as it can be. Okay, so that's exactly what I said right down here. You just take this -1 and put it in here. Okay, and so this is, you have, let's see, let's write out, what is this equal to, folks? This would be -16 quantity squared is the same as 16 squared. And so that's 256. And then let's see if this late at night I can, this is -234, right? And so we get 22 as our answer. And the fun thing is to use technology to graph this. It's not particularly easy to graph by hand. I don't know if I could do it. But this is, would be your, some people, what, absolute max, you know, absolute max. Global max. Now, it's not really important, but it does happen when theta is equal to pi. And because of the periodicity, you can just add multiples of 2 pi, right? So it's pi plus or minus 2 pi n, where n is just any integer, right? Okay, n's any integer. So how do you say that? N's a member of z, right? So when z is equal to 0, you just get, you get pi. So if n's a member of z, z's Zahlen, German Zahlen for z. Okay, so 22 is the answer, is what I got, ladies and gentlemen. Let me write it up here. Maximum value is 22. And I guess you could get the minimum value pretty easily from here too if you felt like it, okay? Anyway, we've solved this problem. And it's similar to a recent SMO Senior problem, number 3, I believe. I think I recorded that correctly. But anyway, that's the answer that I got. And let me know if I made any mistakes. I think I got it right, though. And it is kind of interesting, isn't it? Because if these weren't trigonometric functions, this would never achieve a maximum value. It would just be an unbounded parabola opening up, right? Right? I mean, it's just a parabola opening up. But here, you do get a maximum value because cosine itself is a bounded variable, if you will. A's unbounded here is the difference, right? In other words, you have a between minus infinity and infinity. So that's the difference, I guess. And so it's unbounded, but cosine is very bounded. Okay, so that's what makes this thing a doable problem. Okay, all right, that's it. Thanks for viewing.